So today we're going to move on to integration by substitution. This is where we start being able to do composite functions and integrating them, because you've seen stuff before, you're like, I can't do that. So now you'll be able to do some of it. So we have remember the chain rule is the derivative of f g of x is the derivative of f g of x, times the derivative of g of x. So the derivative of the outside times the derivative of the inside. So the antiderivative is backwards. So antidifferentiation of a composite function, the same general stuff. Let g be a function whose range is on an interval I, and let f be a function that is continuous on I if g is differentiable on its domain of f. The antiderivative of f is an antiderivative of f on the interval. Okay, so all of that just tells you that if I have the integral of f of g of x times g prime dx, then it is f of g of x plus c. So we didn't take the antiderivative of the inside, we're taking the antiderivative of the outside function, and that's an important distinguishing factor. Okay. You can write it in terms of u, which I like to do because we are going to move into differentiating by substitution, but today I'll probably stick with g of x and f of x. So it says let u be g of x, so the inside function, du is the derivative of g of x dx. So we can also state it as the integral of f of u du, which makes it a little cleaner. Again, the outside function, inside function, then the derivative of the inside function. That's outsides, insides. It's about like when we learned the chain rule. You're like inside, outside. We got to keep things separate. And again, it can be on top of each other. It's repeated in integration, and it's fun stuff. You'll get to experience it. Are we all good?
Yeah.
Okay, so we have the integral of 2x times x squared plus 1 squared dx. So we need to figure out, part of your assignment today is figuring out f of x and figuring out g of x. So what is the outside function?
2x.
X squared. Because we have the quantity squared. So x squared would be the outside function. Or something squared would be the outside function. G of x is what? What is the inside function? X squared plus 1. Now I know why you told me it was 2x. Okay. What is the other part of this I need to have? I need to have the derivative of g, correct? So what is the derivative of g?
The derivative of g is
2x dx. So 2x dx. So it's not written in the same order, is it?
No.
But in multiplication, does it matter what order it is? No. So if you feel more comfortable when you have these, writing them as the integral of x squared plus 1 squared times 2x dx, you can do that. Okay? So the rule was the integral, as long as I had f of g of x and then g prime d of x, I could do the integration, right? Okay, so all we're integrating is this quantity, this outside function. That's why I wrote x squared. So what is the integral of x squared?
1/3 x cubed.
1/3 x cubed, but x is the whole inside function. So x squared plus 1 cubed plus c. So we can check this by taking the derivative of this function, correct? So dy dx would equal 3/3, right?
Yeah.
X squared plus 1 squared times 2x. And that's a 1. And so do we get what we started with?
Yeah.
Yes. So a lot of today is just being able to find inside, outside, the first part of it. What's the inside? What's the outside? I'm really sure I assigned you those. Yes, 5, 6, 7, and 8. Okay, so I have the integral of 5 cosine of x dx. Do you think you might want to rewrite this one?
Probably not, since it's
Well, okay. What is the outside function?
x.
Cosine.
It's in the middle, Mrs.
No.
Blake.
You have to distinguish. That's why I asked if you wanted to rewrite it. So you could rewrite it as the cosine of 5x times 5 dx. What function has another function in it is what you need to ask. So when I look at this problem, the only function that has something else in it is where? Right there. Okay, so f of x is the cosine of x. G of x is 5x. G prime of x is 5 dx. So do we have all those pieces covered? We have 5 dx and we have cosine of 5x. So now we just take the integral of this outside function, this right here, that f of x we wrote down. So the integral of cosine of x is sine of 5x plus c. Okay. So I have the integral of x times x squared plus 1 squared, quantity squared, dx. You are going to see that derivative in front of those parentheses a lot because that's how we write things, correct? So I'm going to move this.
You're not.
Yes, I am. I'm going to move this x back
That's not the
here.
same one.
That's not the same one? Nope, this is substitution.
That's also not the same one. There we go.
There we go. I'm going to move this x behind my composite function. So I'm going to have the integral of quantity x squared plus 1, that's a plus, squared times x dx. So what is f of x? X squared again. What is g of x? And you should start noticing we have an issue. And 2x dx. What issue do we have?
X dx, 2x dx, they don't match.
They don't match. Because if I have the integral of f of g of x g prime of x dx.
Hey, stop doing that.
Well, there's a little arrow there, and it like I can't put my x. Nope. You have to know there's an x there, okay? Because it won't let me do it. To have this, I'm missing this 2, aren't I? So if I'm missing that 2, what made the 2 reduce to 1? What did I multiply it by to get to 1? A half. So we're going to rewrite this again as 1/2 the integral of x squared plus 1 squared times 2x dx. Because when we're doing integrals, this 2 right here could come out, couldn't it? It could be factored out. Yep. Okay, so now we have it set up right. We're going to integrate the f of x. So I have 1/2 times, it's the integral of x squared, 1/3 x cubed plus c. So my answer is 1/6 x cubed plus c. Oh, nope, not x cubed. I need to replace the x, don't I? Sorry.
Well,
It shouldn't have been x. I was still doing this up here. I didn't replace it back in my brain. I was differentiating this and didn't replace it with that. So it's 1/3 x squared plus 1 cubed plus c. So 1/6 x squared plus 1 cubed plus c. Sorry. I was already doing my change of variable, and that doesn't work too well if I haven't taught you how to do it yet. Question, Kale?
yeah.
Is that a yes or a no?
That's a yeah.
Which question?
I don't know. We had. I don't know. Where's 2x go? Where? How did that happen?
Okay, we're going backwards.
Yeah.
So when we go backwards, we only integrate the x squared. Okay, so
Why is
let's
it written down there? If we
let's
don't
take
use
what?
it? So then why is it written down there if we don't use it all?
Well, because we have to make sure we cover everything that's supposed to be there. So that 2 wasn't there, so we had to put the 1/2 in front of it. Because that was how the 2 reduced to 1.
But there's still an x there.
Not when you integrate. Okay, let's differentiate this. Okay, so if I differentiate this, I get 3/6 times x squared plus 1 squared times 2x.
Mm-hmm.
Okay, so I get 1/2. 1/2 times 2 reduces. And do I have the original problem?
Yeah, but how do I know to get rid of it?
What do you mean to get rid of it?
From your first equal sign to your second equal sign.
When you go from here to here, when you're doing integration, you're only integrating the outside function. That's how the chain rule works.
Well, how was I supposed to know that?
Because that's what I did the first time.
Well,
And on the first, right here, I'm going to touch it and it's going to go away. Right here. The integral of this, remember that capital F means the derivative of f of x?
yeah.
Well, it's f of g of x, actually. So you're only integrating, and that's why it's hard to go from what you've been to what you've been doing where you've accounted for every single thing in front of you, right? But now we have to remember how the chain rule works and then how it undoes itself.
Okay.
Okay? I want to make sure that you guys are okay on figuring out F and G. So I think my next one, yeah, that's substitution. Okay, so disregard that this slide is... Okay, so this is going to go into your assignment. So number 5, it says in exercise 5 through 8, complete the table by identifying U and DU. U is G of X, and DU is G prime of X. So number 5... is the integral of 5x squared plus 1 squared times 10x dx. I gotta erase my, because I didn't make it big enough. I also want you, I'm going to change the directions. I want you to identify f of x. So we're going to find f of x. We're going to find u, which is the same as g of x, and we're going to find du, which is equal to g prime of x.
Just like what?
Just like we've just been doing. I just want to make sure we can do this. Okay, so what is f of x?
X squared.
X squared. What is g of x?
5x squared plus 1.
And derivative of g.
10x.
Okay, so are all my parts there?
Mm-hmm.
Yes, actually, it's 10x dx. Don't forget your dx. Just show it's the derivative. I know. It's one of those things you just got to get. And when we do substitution by parts, yeah, you really got to remember. Okay, so I have the integral of x squared, the square root of x cubed plus 1 dx. So this is one we would rewrite, wouldn't we? We'd put that x squared behind. So what is f of x?
X squared.
Okay, which function has a function inside of it? It's the square root of x.
I did not know we were on a new plan.
Oh, sorry. Okay, and so what is g of x?
X cubed plus 1.
X cubed plus 1. So du, which is g prime of x,
X squared. Dx.
be 3x squared dx. So what's missing here? How did the 3 go to a 1? A 1/3, right? I can't get the screen to, there we go. It like moves around on me on my tablet, and you guys can't see any different, but mine is like I lose it. So when we would write this to actually integrate it, we would need to put 1/3 in front of it, wouldn't we? Okay. I'll switch colors so we can know that we're in another problem. So 7, but that doesn't help you when it just shows you gray, does it? Sorry, I'm trying. So tangent squared of x, secant squared x, dx. Now we need to think about our trig rules, don't we?
Well, secant squared is tangent. At some point.
Your derivative rules.
Yeah.
Isn't the derivative of secant What's the derivative of tangent?
I don't know.
Look at your sheets. Don't you have derivative sheets?
No.
I had one. I don't know where it went.
Like, I thought you all had them.
No, I've never made one.
You better.
Only time I've ever-
Secant squared x.
Okay, so tangent is secant squared x. Right? But I have tangent squared. Okay? So what's the derivative of secant?
Secant x tangent.
Secant x tangent x. So I'm like, did I write it right? I did. So the derivative of tangent is secant squared. Okay. But we have a tangent squared. So what functions inside what function? And secant, isn't that secant tangent? Yes. Oh, so we could be missing something, right? So I think it's this one. I think the outside function, because it would be tangent, nope. I'm trying to think about this. Because if we say tangent is the outside function, but isn't this just, I'm going to rewrite, I'm thinking out loud. Isn't it tangent of x squared? I mean, that's what tangent squared means, right?
Oh, some.
So if I took the derivative of this, I would get 2 tangent, and I wrote sine. I get 2 tangent of x, and the derivative of tangent of x is secant squared. Yes?
Yeah.
But that doesn't give me tangent squared, does it? So then if I said it was secant,
There's no way this problem is hard. I feel like this-
squared, I think we're just thinking because we haven't done a whole lot with trig functions in a while, right? So this would be 2 secant of x times secant tangent. And we still don't have a, we have secant squared, right? We don't have a tangent squared. Let's do the next one and come back. Ooh, that one's probably going to even be more fun. It's a tangent thing. I can't leave this one up. Can you? I can't walk away. Other ideas? What do you think? No. I was like, no, I don't want to think about that. We're on 4-4, right? Nope, 4-5. It might not be in my book because this book isn't for this one. Okay, so it says our function is tangent. Oh, it says g of x is tangent.
So would both f of x and g of x be tangent then? And then you'd have tangent squared.
Right.
And then the derivative of g of x would then be the secant squared.
So let's try that out. That's a good thought. We got a mess going on. Well, I wanted to say tangent was the outside function, but I'm like, it can't be the outside function. But you know what? It might be. So you're saying tangent
So like,
of x
are f of x and g of x the same?
and tangent of x. But that would be the tangent of the tangent of x. That wouldn't multiply them together, right?
I don't know.
Nah. Okay, so if tangent is g of x, so that means g prime of x is secant squared of x dx. So that has to be f of x is x squared then. And it's missing then what are we missing?
I don't know.
A 1/2. You'd have to be missing a 1/2. Because you're going to have tangent of x squared. So x squared is my f of x. So then it would be 2 tangent of x times the derivative of tangent, which is secant squared x. That still only gives us one tangent. Okay, I have to look into that one more. I get this part. I get the g of x, but the f of x is my question. I will have a correct answer for you on Monday, okay? So 8. Probably before I even leave tonight because I'll be insistent on figuring it out. So we have the integral of cosine of x divided by sine squared of x dx. Well, I'm looking at g of x as sine. That's where my brain, because it's sine squared. So g of x would be sine of x, and then it would be cosine of x dx for g prime of x. My prime's not very good over here. So I'm going to have to do a good one on this one too. That's what I get for putting stuff on the assignment that's not on the assignment. So on Monday, I will give you the answers to these, both the f of x and a good reason, because I need to mess with them a little bit. Do you both see why sine of x is our g of x? Because down here, it's sine of x squared. Okay. And with trig functions, that's really hard to see at first. You might want to rewrite it like this so your brain, I mean, we worked with it a lot last year, but we didn't work with it like this. So that would be my helpful hint to you. You do not have any trig functions today. None. They're all just basic. Now you only have to do 9 through 18. They're all just basic like we did in the assignment or notes.